All right, welcome back to the Deep Dive. Today we're diving into a pretty buzzy new paper in machine learning.
Oh yeah, this one's getting some attention.
It's called Shifting Perspectives, Steering Vector Ensembles for Robust Bias Mitigation in LLMs.
Catchy title. Definitely grabbed my attention.
And, anyone who's keeping up with the world of LLMs knows that bias is, well, a recurring problem.
It is, yeah. It's a huge challenge for the field.
And it's not just a theoretical thing, it has real consequences.
Yeah.
Potentially making systems unfair or even amplifying existing biases in society.
Right, exactly. And as these models become more and more integrated into, well, everything from creative tools to decision-making systems, it's crucial that we really understand these harms, these representational harms, and figure out how to mitigate them.
Totally. This paper kind of hits the nail on the head with this problem. So it starts by laying out just how persistent social biases are in LLMs, despite, all the efforts to fix them.
Yeah, it really dives into the limitations of existing methods.
Right, like prompt engineering, fine-tuning, reinforcement learning from human feedback.
All those techniques have shown some promise, but they often come with their own set of issues, like being computationally expensive or even introducing new problems.
Exactly. So this paper presents a really intriguing new approach. They call it activation engineering.
Yeah, and it relies on these things called steering vectors.
Steering vectors.
Yeah.
So can you break that down for us? What exactly are these things?
Sure. So imagine the knowledge of an LLM is represented in this multidimensional space, right?
Okay, lots of dimensions.
A steering vector is kind of like a direction, a specific direction in the space that corresponds to a particular concept, in this case, bias.
So like a compass pointing towards bias.
That's a good way to put it. And the idea is that by identifying and manipulating these steering vectors, we can nudge the model's output in a less biased direction.
Okay, so how do they actually find these steering vectors?
Well, they use what they call contrastive pairs of prompts. Let's say you're working with a model that shows gender bias in how it writes about different jobs.
Like associating certain jobs more with men or women, that kind of thing.
Exactly. So you could have one prompt that elicits a potentially biased response, like describe a typical software engineer, and another that's designed to be more neutral, like describe the skills needed to be a successful software engineer.
Okay, so you're setting up these two contrasting scenarios.
Right. And then you compare the model's internal activations, the signals that are firing within the model, in response to these two prompts.
And by looking at the differences, you can figure out which direction in that multidimensional space is associated with the bias.
Precisely. And that direction is the steering vector. And what's really cool is that you can actually apply a scaled version of this vector during the forward pass, meaning when the model is generating text, to kind of nudge its output in a more balanced, less biased direction.
So it's like you're making these micro adjustments to the model's thinking as it's writing.
That's a good analogy. And what makes this paper so exciting is that they've gone beyond just using individual steering vectors for specific biases. They've introduced this idea of steering vector ensembles, or SVEs.
Ensemble, so like a team of steering vectors working together.
Exactly. Instead of just having one vector for, say, gender bias, they create a whole ensemble of vectors, each targeting different aspects of gender bias, and then they average them together.
Okay, so why the averaging? What's the benefit of that?
Well, think of it this way. Each individual steering vector might capture some noise, some aspects that aren't universally related to the bias you're trying to mitigate.
So like idiosyncrasies of the specific data they were trained on.
Exactly. But by averaging across multiple vectors, you kind of smooth out those idiosyncrasies and end up with a more generalized, robust representation of the bias itself.
So the ensemble becomes this sort of universal bias detector.
You could think of it that way, yeah. And the paper shows that these SVEs are really effective at reducing bias across a range of different LLMs.
Now, you mentioned that they tested this on several different LLMs. Can you tell us a bit more about their experimental setup?
Sure. So they used 3 different LLMs, Mistral 7B Instruct, Llama 3.18B Instruct, and Quinn 2.57B Instruct. These are all pretty powerful and popular models.
And they wanted to see how well their steering vectors worked on different architectures.
Right. And to evaluate the effectiveness of their method, they used a dataset called the Bias Benchmark for QA, or BBQ dataset. It's a benchmark specifically designed to test for social biases in LLMs.
Okay, so that makes sense. And what about measuring the impact on the model's overall performance? Because, we don't want to fix bias at the cost of making the models less capable in other areas.
Of course not. That's a key concern. So to address that, they also use the MMLEU dataset. It's a benchmark for general language understanding, covering a wide range of topics and tasks.
So they wanted to make sure that reducing bias didn't mess up the model's ability to answer questions accurately or understand complex language, right?
Yeah, exactly. And the results are pretty impressive.
Tell me about it.
So they found that their individually optimized steering vectors led to some pretty significant improvements in accuracy on the BBQ dataset across all 3 models.
So that means the models were giving less biased answers to the questions in that benchmark, right?
That's right. But even more interesting, the steering vector ensembles did even better. They consistently outperformed the individual vectors, indicating that this ensemble approach is, well, it's more effective at mitigating bias.
And crucially, what about the MMLU results? Did reducing bias come at the cost of general performance?
No, not really. In fact, in some cases, the SVE even slightly improved performance on the MMLU.
So it's not a zero-sum game. You can actually reduce bias and potentially even make the model smarter overall.
It seems that way. It really suggests that this approach is on the right track. It's also worth noting that they found the optimal way to apply these steering vectors might differ depending on the specific LLM architecture.
Oh, so different models might need different doses of this steering vector, so to speak.
Exactly. And they also found that their method showed promise in addressing what are called intersectional biases.
Intersectional biases, those are the really tricky ones, right?
Yeah. So for example, biases against individuals based on both their race and gender or their age and socioeconomic status. It's encouraging that this approach seems to generalize well to these more complex and nuanced types of bias.
And it shows that steering vectors might be a more powerful tool than we initially thought.
Right. And it really highlights the importance of systematic, data-driven approaches to developing these techniques.
To kind of back up a bit, can you put this work into the broader context of research on bias in machine learning?
Sure. So, awareness of bias in these models has really grown in recent years. Early research was mostly focused on detecting and measuring bias, using different analysis techniques.
So kind of trying to figure out how bad the problem was?
Exactly. And then we started to see techniques like adversarial debiasing, which is a way of training models to be more resistant to adversarial attacks that try to exploit their biases, and also fine-tuning models on carefully curated data sets that are less biased.
So those are kind of data-centric approaches, right?
Yeah.
Trying to fix the data that goes into the models.
Yeah, and they're definitely valuable. But activation engineering and these steering vectors, they represent a more recent and potentially more direct way to intervene in the model itself.
So instead of fixing the data, you're fixing the way the model thinks.
Yeah, you're adjusting the internal workings of the model, which is pretty powerful. And this builds on earlier work that showed how manipulating these internal representations of language models could be used to control things like sentiment or style of the output.
Right, like making the model sound more positive or more formal, that sort of thing.
Exactly. But now we're seeing it applied to these really complex social biases, which is, it's a huge step forward.
It is, yeah. It feels like we're moving beyond just treating the symptoms of bias in the text that the model produces and actually starting to address the underlying way the model understands the world.
Absolutely. It's a much more fundamental approach.
And as you said, a much more interpretable approach. With these steering vectors, you can actually see which direction in the model's representation space is associated with a particular bias. That's a huge advantage over some of the more black box methods.
Yeah, interpretability is crucial, especially when we're dealing with something as sensitive as bias. It helps us understand how these interventions are working and build trust in these systems.
All right, so for our novel notions segment today, let's brainstorm some potential future directions for research based on this paper. What are some new avenues that come to mind for you?
Well, one thing that struck me is that the current steering vector ensemble approach is kind of static. It's like you have this fixed set of adjustments that you apply uniformly across all contexts.
Right. It's a one-size-fits-all solution.
Exactly. But what if we could make these ensembles more context-aware?
What do you mean by that?
Well, the paper shows that individual steering vectors are good at targeting specific types of bias, right?
Right. Each vector is like a specialist.
Yeah. So what if we could develop methods to dynamically adjust the weighting of these vectors, or even select which vectors to use based on the specific context of the input or the conversation that's happening?
So the model would have a sense of which bias filters to apply based on what's being talked about.
Exactly. For example, if the conversation is about career paths, biases related to gender or socioeconomic status might be more salient.
And those vectors would get more weight.
Right. But if the topic shifts to something else, like historical events, then maybe biases related to race or nationality become more important, and those vectors would be emphasized.
That's a really cool idea. So it's like the SVE would become this dynamic adaptive system, constantly adjusting itself to the context of the interaction.
Precisely. It would be a much more nuanced and sophisticated approach to bias mitigation.
Though I imagine there would be some challenges in actually implementing that. Like, how the model know which biases are relevant in real time.
Right. That's a key challenge. It would require some advancements in real-time bias detection and analysis of the ongoing conversation.
Yeah, but it seems like a really worthwhile direction to explore. What about other novel research directions? Anything else that this paper sparks for you?
Another thing I was thinking about is the potential for, unintended consequences or even adversarial uses of steering vectors.
Oh, so kind of like a flip side to this whole approach.
Exactly. I mean, this paper focuses on using steering vectors to mitigate bias, which is great.
But you're thinking, what if someone used them for the opposite purpose?
Yeah, what if someone figured out how to create steering vectors that actually introduce or amplify bias? It's not inconceivable.
That's a bit concerning, but I see your point. If these vectors can be used to steer the model in a good direction, they could potentially be used to steer it in a bad direction too.
Exactly. So I think a really important area for future research would be to investigate this adversarial landscape of steering vectors.
Like trying to figure out how easy it would be to create these harmful vectors and what kinds of biases they could induce.
Yeah, and then based on that, we could start developing defensive strategies, maybe creating counter-steering vectors that could neutralize the harmful ones, or building in robustness checks to make sure our SVEs aren't susceptible to these kinds of manipulations.
So it's kind of like an arms race, but for bias in LLMs.
In a way, yeah. It's about understanding the potential risks of this technology so we can build more secure and reliable systems.
I mean, it's kind of like any powerful tool, right? It can be used for good or for bad. It all depends on the intentions of the people using it.
That's a good point. And it highlights the importance of ethical considerations in AI research and development.
Absolutely. All right, those are some really interesting and thought-provoking directions for future research. And it just goes to show that this paper is, well, it's more than just a technical achievement. It's a starting point for a whole new way of thinking about bias and how to address it in these powerful language models.
I completely agree. This paper has definitely shifted my perspective on what's possible with bias mitigation.
To wrap things up, I highly recommend checking out the full paper, Shifting Perspectives, Steering Vector Ensembles for Robust Bias Mitigation in LLMs. We'll have a link in the show notes. It's a fascinating read and offers a lot of promise for building fairer, more reliable AI systems.
Definitely worth a read for anyone interested in the future of LLMs.
And that's it for this week's Deep Dive. Join us next time as we explore more cutting-edge research in machine learning.
See you then.
All right, take care.
You too.